What are Kubernetes CRDs, and why should you use them? Imagine building a house with your own custom furniture that fits perfectly. In Kubernetes, custom resource definitions are like that custom furniture. They let you add your own pieces to the system. Kubernetes naturally understands pods, deployments, and services. But what if you want to manage something unique, like a database cluster or a special network setup? CRDs make that possible. They are a way to extend Kubernetes by defining your own resource types. Think of a CRD as a template that describes what your custom resource looks like, how it behaves, and how it should be validated. Once you create and register a CRD, Kubernetes treats your new resource just like any built-in object. You can create, update, and delete instances of your custom resource using standard commands. When you define a CRD, Kubernetes adds a new API endpoint for it. This means your custom resource becomes a first-class citizen in the cluster. For example, if you create a CRD called database, Kubernetes creates an API path where you can manage database objects. These objects are stored in etcd, Kubernetes Distributed Key Value Store, just like pods or services. You can scope CRDs to specific namespaces or make them available across the whole cluster. Namespace-scoped CRDs are limited to a specific project, while cluster-wide ones are accessible everywhere. Using CRDs opens up many possibilities. They allow you to automate complex tasks, like managing custom applications or infrastructure components, all within Kubernetes. Many tools like Helm charts and operators relying on CRDs to function. For instance, operators use CRDs to define the desired state of applications, automating updates and repairs. In multi-cloud setups, CRDs help standardize resource management across different providers like Amazon Web Services, Microsoft Azure, or Google Cloud. You can create custom resources that abstract cloud-specific details, making your deployment process smoother and more consistent. Security is also straightforward. You can set role-based access control policies to control who can create or modify your custom resources. Audit logs track all changes, helping with compliance and troubleshooting. To create a CRD, you write a YAML file that specifies the API group, version, and schema. The schema includes validation rules to ensure your custom resources are correctly formed. After applying this YAML with a command like kubectl-apply, your CRD becomes available immediately. You can then create instances of your custom resource by writing YAML files or using commands. Think of the CRD as the blueprint, and each custom resource as a house built from that blueprint. For cloud teams, CRDs help keep resource definitions consistent across different environments. They support GitOps workflows, where infrastructure is managed through version control, making changes traceable and repeatable. Because CRDs are dynamic, they can be added or removed without stopping your cluster, giving you flexibility to evolve your infrastructure smoothly. Overall, CRDs are a powerful way to extend Kubernetes, making it more adaptable to your specific needs. They help you automate, standardize, and manage complex resources, all within the familiar Kubernetes ecosystem.